let's get going. So, for today, I'm picking up where I left off, sort of, although I made a little bit of progress. So I had decided I wanted to get more serious about this generator, so I built out a lot of to-dos at the end of my last stream. And I've actually done a little bit of work off stream. So to get you caught up if you've been following from one to the next, let me check something. So just got a weird... Okay, everything's good. So one thing I did is I did start working on these loosely arranged section systems, and let me show you how that's working. So I've got these sections, and when I generate them right now, I have this section push function. So I make a list of sections, and right now I'm giving each section a name, some data, a virtual offset, a virtual size, and some flags. So what I want to do is I kind of want to diagram out, like, this was just a hacked sketch thing. Let me go through the steps of what this new code actually does, what it's currently offering, and I also want to kind of think about the architecture here, where decisions need to get made. So we're going to be doing some kind of like API design, but it's pre-coding. It's not going to be write the functions first. It's going to be think through the use cases with a diagram kind of approach. So we'll get to do my diagramming style today for a while. Then I create one of these layout things. So the layout is going to take my loosely arranged list of sections and figure out how they're getting arranged into the file. And so it generates these f-offs, which we already had v-offs, virtual offsets, but we didn't have file offsets for these data sections when we first created them, because we kind of want to have a spot here where someone who is thinking about what data to include in the binary can put the data in without having to know specifically where the data lands. And there's a couple of reasons why we want that. The main reason is we want to figure out how big the header is automatically. The header contains a few, like it contains a DOS header and a PE header and a COFF header and then an optional header and then these list of directories, and then there's also the section table. And so once you've gotten all the number of sections is a variable that determines how big the header is, and so where the header ends can only be determined automatically once we know how many sections there are, right? But that means if I'm working on a file and I'm like, let me add a new section, well, that increases the size of the section table. That might rearrange the layouts, right? And so I want to automate a thing that says, okay, looking at all of the information we have about our file headers, calculate the size of the header, and then begin from there laying out the sections as necessary into the file. So this part here lays out the sections to give them spots in the file, and I want that to all be automatic. So that's what the layout section is doing. I come this far through the system, and I can just say, like, I don't need to know how many when I lay out the section table and when I lay out the sections, I'm just reading off of the final layout. Now, right now, the way this works is the layout right here takes in the section list, and the layout struct itself just contains this part here does all the layout work. So it looks at the list of sections and figures out where everything is going to go. But there are still some issues. Like, now I have to decide the virtual offsets manually still, and there are lots of ways that can go wrong too. Maybe all I want to do is give it the data and have it figure out what to do, but there's a problem with that, which is sometimes the data you want to put in the file is different from the data you want in the image once it's loaded. The virtual size and the file size won't always be the same. This can happen, for instance, if you have a section that's going to be cleared to 0 at the beginning of the program. Well, you don't need a data section in the file for that contains anything, right? I can have an empty string for the data, but then the virtual size can be 6 kilobytes or whatever, right? 8 kilobytes, whatever you need it to be. Vice versa, you can also have more data in the file and say, like, hey, this is sort of like debug data. You actually don't need any of it. So when you load this in, only take the first, 1K, and the rest is not actually part of the image. These are both valid things that can and do happen. There can also be like padding in the file that you just don't want to load in to the virtual space necessarily. There's no need to copy it in. So it's not clear that I want to be manually laying out the virtual stuff either, but I do at least need to be able to say, like, here's the data block that goes in the file, and also here's the virtual size, right? There's other stuff like the file sizes are being lined up to the file alignment. So we have these things called file align, right, and virtual align. Now I'm just treating those as fixed things right now. These are like defaults that are pretty much always appropriate, so I could just leave them that way. But we might want to think about, like, if someone did want to parameterize that, when is that parameter significant? That parameter is significant by the time you get to layout, for sure. So maybe these are parameters to layout. Like, I don't know. So with that intro, what I want to work on today is I can generate a data file or a binary file with a text section like this, and that's working. That's good. But I want to try to add in a second section now and see if it works. I want to start there. And I want to do some other things. Like, I want to be able to rearrange the sections so that they can come in different orders and have it still work. There are things like text voff and entry point voff that are not automated, and maybe they should be automated too. There's also image size, which is not being automated, but that I think I could actually start automating. Let me look at that. Yeah, so I actually did build that. So let's get the image size off of the layout and the header size off of the layout. We'll start right there. First change of the day. Okay, it's still running. And when I pop in over here and I reload it, rerun, everything's still parsing. Okay. By the way, the new the exe, if y'all haven't seen this part yet, the exe that we are generating right now is I think it's 1 kilobyte, which is cool. Generated, yeah, there it is. See this? Generated exe, 1 kilobyte. Mm-hmm. All right. Now we're going to try putting down some data. Read, write, memwrite. Contains initialized data. More stuff I want to automate. The header here has total size of text, total size of initialized data, total size of uninitialized data. Okay. And I'm going to put a little goal on this. So our data is going to look like this. So right now, my assembly, so this thing, I'm going to pop in here on a little Godbolt instance. Because the last time I generated my assembly, I just wrote return 1. But now what I want to do is I want to have it return a variable from the data section. So now what main looks like is right, we're moving something into EAX. RIP plus OX2F00. Piggybank Studios asks, there's somewhere that explains the overall purpose for messing with PE-COFF file format. The main place is here in my announcement of the membership system. I described all of my projects briefly here and in the video. I will probably, for each project, do a more in-depth explanation. Well, like arena use resources, I won't, because that's just, I'm going to just make the resources. But like for this one, I will sooner or later describe in more detail everything that I'm thinking. But this is a quick description right here. To answer the question you're asking, though, or to answer the implied question, the purpose of all of this is ultimately to take a good look at the way we generate a native program, like an executable, and to try to make that as accessible as possible. I think right now we kind of just assume that if you're going to generate an executable, that's going to be the back end of a compiler, or it's going to be a linker, something like that, right? It's going to be a project like that, and it's going to be this big, just like whatever the language is, whatever the tool chain is, it's just kind of going to be glommed on. And I kind of want to get to a point where it feels cheap and easy for you to just play with your executables and make them yourself. Not in sophisticated ways, not using tons and tons of theory, but just like to be like, hey, I'm going to take what the stuff Alan's got and I'm going to spend 2 days just spitting out an executable using this trick. And I don't know if there are going to be reasons why that turns out to be impossible, but I think it's possible. And so I want to spend some time like figuring out what we need to know, what are the core main things we need, and pulling them out, make them easy to understand, make them easy to use. And so I got to spend a lot of time like understanding the space and sort of getting a handle on all of it. So I think what I could do, I could write some assembly that would look like this. It would be mov into EAX. From D word, don't take away my help yet. D word putter, and then let's see. Here's what 4K. Well, let's see. Here's what one. So that right there is 256, 512, 1K, 2K, 4K, 8K. Okay. The problem is that's 8K. RIP relative is so confusing. So if I were to do it, okay, what if I did RIP plus 4K? And then return, right? Okay, let's try this. Wait, did you change my code? Oh, that's annoying. I didn't know that that was how this worked. Annoying. Okay, let me try this a different way. I assume that what must be happening here is this particular compiler is laying out main and then the data section in such a way that... But how are they lined up like that? I don't know. Well, let me just get in there. 8B05002F0000. Let me just write these down. 8B05002F0000. Followed by OXC3. So that's the return. And this is the MOV EAX DWORD putter RIP plus OX2 F0000. Oh, 2F00. All right, little endian. So then what I want to do is I want to say, no. This is the begin. So this right here, if this is my RIP, my large instruction pointer, my 64-bit instruction pointer right here, that'll be at the 4K spot in my file. So add another 4K, and you'll get to the spot I want. $1K, $2K, $4K. Yeah, cool. And so that should load a 2 and return it if I've done everything correctly. OX8B. Good catch. Thank you, Tybarone. That's nice. 8B goes on the first one. Okay, so the generator crashed. That's good because when the generator crashes, it's at least easier to track down what went wrong. That's just something about something being off here. Gensec is bad? Laysec. No section, huh? Okay, so this is happening during the layout function. Let's just check out from the beginning. Oh, look at this. I'm not iterating my sections pointer at all. 76. All right, so we're just tracking down bugs in the loose layout section, which is good, or the loose layout system, which is good. Sections. Layout section. Okay, +1. Section pointers. Merge sort. Okay, cool. Let's check it out from merge sort. So we've got Okay, the sort put them in the wrong order. Probably swap these. That's not bad. The generated code is just returning 0 now. Alright, we're gonna do something a little funky. We're gonna start debugging generated exe. And this only comes with disassembled man, that doesn't lay out very nice, does it? Okay. So that's not hitting the right spot. Let's look at what my laid out file looks like. We do have a 2 right here. Okay. So let me see a couple things here with remedy. Step in when we're right here. This is okay, so that pointer does in fact point to a 2. So I would think that RAX here should be a 2 now. I'm obviously getting something off. The RIP plus the RIP plus 4K does point to the 2. But then the register gets a 0. Alright, so I got some folks who are offering some ideas, which I appreciate. I'm a little bit unfamiliar with RIP relative addressing here. One One person's pointing out, yeah, it might be that they're actually, that the way this actually works is that the rip at the current, but the current rip is not the correct thing to look at. Because we're looking here, we can definitely see that if we took current rip plus 4K and we dereferenced it as a 4-byte integer, right? If we just were like, okay, that's an int. What is it there? The answer is it's a 2, right? So that's what's expected. But it's possible that it's going to actually read, you know, because they're going to be, the rip is about to increase by 6, right? If I F10, this goes up by 6. The reason for that is rip is this arrow here, and it takes 6 bytes to encode this instruction. So it just moved up 6 bytes. Maybe the load is using the rip after the move instruction instead of before. Let's go and actually be rigorous about this. x86-64 instructions. A little Felix. Yeah, a little Felix up here. And then Mauve. How is there any mention of rip? No. What about instruction pointer? I think we're probably going to look at move M32, right? That's the 8B, register 32, memory 32. Address mode. Okay, let's look up this. x86-64 rip in address mode. Okay, so it does, okay. We want to subtract 6. FFA. There it is. Okay. Okay, interestingly, that one can't run. Let's see how the changing order there affected things. Hmm. Hmm. Okay. It did not reorder text and data the way it should have. Let's look at that. Um, so there's this merge sort that happens right here. And the first one has a V off of 8,000. Second one has a V off of 4,000. Afterwards, they didn't change order. Okay, that's not right. Why are these garbage? I think my compare function must be wrong. I think these should be double pointers. And so I'm really doing like this kind of thing. Still not right. Okay. Now when we're done, they're in the wrong order. So maybe my compare order was correct in the first place, and this other thing that I've just discovered was the real problem. And so now I gotta switch it back. And there we go, now it works. So I assume that means when I do this, yeah, it sorts them by V off. So one of the rules that it has to follow when you generate one of these files is that the sections are supposed to be sorted from smallest to largest virtual offsets for each section. So now what? Now what? We got the ability to rearrange our sections. So now we're hitting on the issue of choosing virtual offsets. So this is where it gets a little confusing and tricky. The data inside of these can have pointers that require virtual offsets to be laid out a certain way already, right? It's not the case that I can just be like, hey, make this, instead of having this hang out at 8, let's have it hang out at 12. That won't just automatically work because this right here is encoded with the assumption that this is at 8, right? And so there's like pointers between these that are, they're not assuming that we know where the data is going to go, but they're assuming that we know that all of the data is going to go together, right? So if, for instance, I wanted to shift that up to 12, I could shift this up to 8, and then I have to modify things like these But, that doesn't quite work. What did I miss? There must be another one I missed or something. It might also just not like me skipping ahead like that, possibly. I just get the impression it doesn't like me skipping one of the pages. That's the only thing I can think of that might cause it to not like that. Right, the difference is 4, 8, KB, 4, 4. Then it works. If I do something like this, it's definitely busted, right? It's just go crash. Yeah. It starts at the wrong spot. If I do this, what happens? It just works. So this one might be irrelevant nonsense. But this one actually does tell it where to find that. And if I set this to 8 and this to 12, then what you say is can't run on your PC. All right, I'm gonna look through this. Well, let me look at the generated file real quick. There might also be a clue if I dump it about what's going wrong. Let me start with that. Let me dump what we've got. Section count 2, timestamp. It's optional header size. Flags, optional header stuff. Image size 12K. That seems wrong. Right, because 12K is where this is starting. So what's up with that? Look at that. 113. You have to do the roundup correctly. No, that didn't fix it. Okay. Run the dump again. Image size is 16K now. So that's better. Something's up with the flags printer. So I'll go check that out in a minute. 'What did we miss? $12K plus the virtual alignment gets added in. So that part is right. The hard part about these kinds of problems is this is all we get. We don't get to debug this. We don't get to inspect it. We don't get any kind of visual help. No additional information is coming. Give me a moment. Size of a knitted data is wrong. That could actually be relevant. Size of data file align. That's still not it. I got a cool looking question here. Have you tried something like Ghidra or Radar to analyze the executable? No, I haven't. Let me do a little looking around here. What are these? Because if you've got tools that actually already do what I'm looking for, that would be good to know. This looks like it could be cool, but also probably massive. Ghidra requires a supported version of Java runtime and development kit on the path to run. Okay, so that is... okay. No, I haven't tried those. I'm not sure that that's the path I want to go down. I'm not looking for reverse engineering tool exactly, although it definitely is relevant, hits the right idea. probably would help, but I'm gonna have to choose to avoid it for now. I'll do more research into both of them and how they see what they do, and maybe I'll change my mind. But at least at this moment, if it's a big install, I don't want to just dive into it. Okay, so yes, reload it, reparse it. Yeah, that's not a bad thought. Big Bang Studios. I'm not ignoring it. It's just at this moment, it's not. I don't want to dive into installing a JDK that I don't have and messing with that for an entire rest of the stream. You know, I'll just do a bit of research and then maybe check it out at some point. But okay, so I don't see anything obviously wrong. And so I'm wondering if the reason it doesn't work is just because it thinks that the first section should begin at 4K. Like, I don't know what else it could be. I'm going to go check that out. Yeah, this is imhex. It's a free tool, not a big download, and it comes with some cool stuff like PE format, built-in patterns and stuff, which is cool. It does not tell you why your PE file is invalid and won't run, which is unfortunate. Let's try. So I'm still stuck with this not running. I'm thinking. Let's try and go read in the docs real quick. Maybe they are clear about this rule somewhere. Here we go. In an image file, the VAs for sections must be assigned by the linker so that they are in ascending order and adjacent, and they must be a multiple of the section alignment value in the optional header. I think the requirement that it be adjacent is going to require that the first one is at 4K. Right? It's going to end up saying, hey, you need to put... you need to put things down in an order here that packs them, right? Isn't that what adjacent is going to mean? Like, you can't... You can't skip over a VA. So here's another way we could test that theory. Let's set this back to 4. Hey, Dan. How's it going? But leave the data section at 12. Then what's going to happen is my code is going to be wrong, but we can fix that by just adding 4K to it. So now it should read from this spot. And everything else can be the same. Yeah, it doesn't like that. But if I were to do this, then we're right back to everything working. So I think that's another requirement. The virtual offsets are constrained to start at 4 kilobytes and to grow in a way that, and to be packed in tightly. Packed in tightly while still respecting the minimum alignment rules. Okay, so I think now's a good time to switch to drawing because we're starting to see like there are some rules on these virtual offsets, and so I want to explore I want to explore how I expect this to work as a tool you can use to generate executables over time. Let's start by just writing down some of our data types here. So a section contains a name and a virtual offset and a virtual size and a file offset and a file size and some flags and a data blob. Right? So that's sort of the main idea of what a section is. Now, the question is, how do these relate to each other in a way that simplifies, right? If I made you specify all of these to lay out your sections, things would get annoying. So when I created the layout system, I made an idea of a like generic section or a generator section or something like that. And for this, you still specified a name and a v-off and a v-size. You did not specify an f-off. You still specified an f-size and flags and a data blob, right? So it's very similar, but it's missing the f-off, right? If I can make myself one other color, make it this one, a little bit more of that. There's the main difference, right? All right, hopefully that's better for you. I don't mean to be too far from the mic while I'm drawing. Is that better? Cool. So the main difference then can be understood like this. We can say a gen or a section is a generator section and an foff, right? So if we have a generator section and we can get to an foff, then we can create a section. Now the way we end up calculating our foff is we take in a list of generator sections and we produce a list of foffs that go with them, right? So for this, let me get a blue color here. This is our layout function. And then once we've done that, we can iterate those lists in parallel and we end up with a list of sections, right? So we then finally have this sort of like finalization step where we take a list of gen sections together with a list of foffs and we generate a list of sections. Okay. So here's the thing, like you can see here the section equals gen section and foff. Here you can see the gen section and foff becoming a section. The difference here being that in order to actually get there, we're doing it with lists because the way we calculate an foff isn't directly from a gen section, but from a list of gen sections, right? If we don't have a list of these, then we don't have a way to lay them out. So in order to put this together with the thing that actually lets us generate foffs, we have to apply it to a list at a time instead of one at a time, right? We're hoisting this idea up one level to the list level. Okay. Now, that's cool. That's fine. Let's see. I'm going to do a little bit of sorting and tidying of the notes. Increase their readability. Now, the big question here, is, do I actually want to put voffs right here? Could we get away with a version of this that does not put voffs there? There is this sort of rule that they need to be laid out in a certain way. So the user specifying their sections might just want to say like, hey, here's the name of a section. Here's the data blob. Here are the sizes for when it's in the file, which is just the size of the data blob, and when it's loaded into the image, which could be something different, and some flags to go with it, right? So if you just specify those, then layout would be responsible also for making, we would have to add that it takes a voff to finish a section, and this would generate a list of voffs, right? And then this would also zip in that list of voffs. Right, it'd be something like that. And let's see. How the main question here, the only real question is, can layout actually successfully do this? Can this exist? The way it would work is it would just assume the order you put them in is correct and lay the VOFs out according to that order. But then there's this other problem, which is that there is another constraint on the VOFs. The data inside of the sections might require that the virtual offsets between certain sections remain the same. And so then there's two questions here, right? Question number one. The first thing we would need to have an answer to is, if the data in the sections requires relative layouts specific relative layouts of VOFs of virtual space. Between sections. How do you also comply with the tight packing requirement for the virtual layout? And then question number two, so that's one thing I want to think about. And if we had an answer to that, how does the user want to express or manipulate the constraints of virtual layout between the sections? Okay, so there are a few cases in question number one of how the required layout might violate the layout rules, not just the tight packing rule, but the layout rules in general. So, cases. One. The relative section layout spreads sections out too much. Solution: add padding to the section size. All right, so we could just add in padding automatically. Two, so the other thing that came to mind is the relative section layout overlaps sections. And that one's just unsolvable, I think. So we would need to have some way, if we were going to specify the constraints, we would need to have some way to take in those constraints and generate either, hey, this is invalid because you have at least one case where the constraints are going to push sections closer together than what the alignment rules allow, or even cause them to overlap each other. And so that's just, we can't actually generate layouts those ways. Or the constraints will say, hey, these sections, it looks like you have a text section that wants to be 16K away from a data section, but your text section's only 8K, so we're going to actually have to pad in this text section in order to get the layout correct. Or we're going to have to put in a padding section or something. So that second one is solvable, and it would then be the job of the system to provide the information about where that padding needs to be placed in order to make it work, right? You'd put in your constraints and out would pop either the answer, this cannot be generated, or here's the information you need about how to generate this, how to lay this out so that it all fits. So now let's look at question number 2. Let me how does the user want to express or manipulate the constraints of virtual layout between the sections? I mean, honestly, the user doesn't want to think about it necessarily, but if they do start generating stuff and they have, assembly that's, they got some code. Okay, there's a couple of use cases, right? There's one where they've generated code, right? They're making a compiler. They've literally generated some machine code, and they know that it's um, filled with all these pointers. And in a case like that, I think they want to be able to specify relocations. They want to say this is a pointer to data section plus this much, right? This would be something like a range. It's the range inside of a particular section, or like a location. To be a location inside of a particular section, and a section and offset. So this way you could just say, hey, whenever I put in a pointer, instead of encoding the pointer, I'm going to just spit out a relocation here that says these 4 bytes are supposed to be pointing at this section and offset, right? And then when we actually go and do the layout, we can do the layout however we want, and we just use this information later to modify the data blob, right? So then these aren't really constraints on the layout. There's no invalid layouts. It's just a matter of, or if there are invalid layouts, it's because like we want to fit into 4 bytes something that won't actually fit in 4 bytes or something like that. But that's one option. And I think that might be what you want if you're generating code, because you won't know when you're generating code how much code you don't want to have to know how much code you have, and how much code you have is going to tell you how far away the next section is going to be. So instead you want to encode, hey, later, once we know about the layout of all the sections, come back in and modify these bytes with the correct offsets. And so section and offset together gives us a way to encode a location that is independent of section layout completely. Another idea is constraints, which would be something like, given a pair of sections, and some distance, right? The distance you want between them. So I could say like this section and this section are linked together and they should have this be this far apart. And I could then make an algorithm that says take up all the sections we've got, or take up in all the constraints, and sort of lay out the sections relative to each other. So they'll create these little islands where, you know, if 2 sections are linked, they get linked together. If more sections get linked into them, they all get linked together, and they all have to have compatible distances between each other. I think something like this has a use case that is interesting, which is if I'm not generating the code, then I don't know where all the pointers are, but I know that they got generated somewhere else, like a compiler generated code and gave me an object file. Now, the object file already has relocation, so maybe the answer is to learn about and use the object file's relocations. But let's go the next step. Let's say I've already linked it and I've got a couple of executables and I'm trying to play with them inside this thing. I don't know anything except the layout, the virtual layout of the sections that I've already got. And so I might want to generate a constraint from what I've already got in order to maintain that constraint as I shift things around or insert stuff, right? So the question is, where do I want to start with these ideas? Do I want to build one of them today or build towards one of them? They're both very interesting, possibly very useful. I'm also curious how they would go together. I think, yeah, I'm about an hour and 20 minutes in. Now's a good time for me to take a 5-ish minute break, and I will come back and resume considering this question. So be back in just a little bit. All right. Let's take a look. So if these were going to go together, what would happen is the layout function would become like this. You'd have a list of gen sections and a list of gen constraints. And then what would come out from that on the arrow is you would have one of two things. Either you would have an error if the constraints aren't meetable, or you would have a list of final sections, essentially. Or rather, I think what we were calling it before is like, you know, you just get your list of F off and V off for each section. Right, either you get an error or you get a layout. And that is what the layout function would do. And then what would have to happen is there would be a relocate step, right? So you would take your list of gen sections and we're just assuming the gen sections have relocations attached to them. You would take in that list of V-offs, which could also be the list of F-offs and V-offs, and you just ignore the V-offs, but you would take in those V-offs, the final layout of V-offs, and you would relocate them, essentially modifying the gen sections in place. So something like this. We're going to do that. This would be relocate. And this right here is destructive on that one. Right, so we're going to destroy this version of gen section in order to create this version. Okay. So I think I can see how it would all work. Let's Okay. Okay. So now the question is now the right time to do that? There's some baby steps we could make, right? So this is a big change to how layout works and would require me building the gen constraints. We could go down that path. I could also just make the first baby step, which would be take the V off here, apply them here, and leave this empty. So the layout would be basically equivalent to the case where you just didn't get past any constraints for the layout. And then later we could add in those constraint parameters, and we'd still be making progress. It's less featured, but it's like a correct baby step, right? I think so. Let's do this. Let's just do this part and see how it feels after that. If it's time to do building a new structure and complicating the layout algorithm, or if we maybe want to do the relocate, or if we want to take on a different problem. But I think we've got a picture here that makes sense. So let's do I want to start by renaming these because I called them sections initially, but I think gen section is a better name since they're not technically full sections, and I called the variable version of them gen section as I started realizing that. Let's just get the types to match the rest of the conventions. Yep, one space indentations. My virtual white space though, it's actually two spaces when I save the file, so you can see here's 2-space indentation. But I have the editor run virtual white space as if it's one for myself. I know that a lot of people really hate one space, so I save it as 2. So when you're reading it online in my repos and stuff, it looks like 2-space indentation, which is still weird, but a little more space. But yeah, for me it's 1. 1 is the way to go. Nice, cool. Also, are you on is also like a Linux graphics like Windows Manager kind of? Is that what that is? I can't remember. I've heard the name before. Okay, so also is Audio. Interesting. You should go hang out in the 4Coder Discord and ask. Someone could probably like give you a build that disables that, or point you in the direction of how to do it. It shouldn't be too hard. The audio stuff in 4Coder is extremely minimal and not necessary. Okay, so gensec currently takes in a voff. We're gonna say nope, you do not. No voffs, just a vsize. The fsize comes from the data blob. No voffs. There we go. No voffs. No voffs. No voffs. No voffs. I think that, yeah, so my recommendation is, I do think that a lot of people try 4Coder and it works for them. And if you want to get into it and configure it to like tune it up to exactly what you want it to be, I would go hang out in the 4Coder Discord. So to find that, you can go to 4coder.net, ignore the security problem, and click on the Discord link. It says Handmade Network Discord, but it's actually going to take you to the 4Coder Discord. I haven't updated the website in a long time. I don't know how that link got out of sync with the text on it, but that's what it does. So if you go there, the people who do hang out there are still active enough that you can get some help with the configuration, and that's kind of good to have. But it's hit or miss. Some people try it out, and I don't think it's for everybody. But if it is for you, there's a good chance that you can get in all the cool tricks that you can imagine. If you spend, it could take like a month to go from base 4Coder to something that you've really tuned up to your preferences. So that'll give you an idea of like if it's the right kind of thing. Configuring an editor is one of those things. It doesn't matter if you use 4Coder or Emacs or Vim or anything else. Configuring an editor is one of those things. But the fun part is in 4Coder, you can configure it by programming some wacky wild shit and see whatever you can think of, right? So when you're done, sometimes you've made a little bit of magic. Okay, so I've taken the voffs out. What we want to do is in the layout function, we now want to generate those voffs. So the list I was talking about before is a little bit oversimplified, right? I said it was just a list of foffs and voffs that are parallel to this. But the way I actually do it is I create an array with a pointer back to each gen section, because I might change the order. And I didn't really represent this honestly here, but it's correct. Like, this right here is still good enough. If you could imagine another way I could do this is to lay things out exactly parallel to this, but have the voffs here not be in order, and then as they come out, they would be in order. But you still also need the sorted order of the voffs at some point, right? So that's something that's kind of coming out of the layout system, is the sort as well as everything else. Right now, we've taken out any need for a sort because our voffs are now up to us. We're laying them out. We're no longer getting them from the gen sections. We're gonna have to generate them. So we're gonna have to right here generate. Well, let's see. We want to calculate the header size. That definitely needs to go here, because then we can lay out the virtual space. And that can look like this. align up power of 2, headers size, vert align, right? So we start off with our VOF cursor there. We're going to look at each section and give it a VOF from our VOF cursor, and then we're going to align up power of 2 from the gen section's V size and the virtual align, right? So that generates the VOFs for us. We're incrementing the VOF cursor by the size of each section and then adding in the alignment as well. And it starts off aligned, it gets incremented by aligned values, so it's going to stay aligned. And then it's going to fill out the VOFs. So once we have that, we now know it's sorted. In the future, it might not be, because this might start mixing in constraints. And once we have constraints, this will get all spicy, right? This will start easy, but once we know the header size, we can do the virtual layout. And with constraints in the mix, this will be all interesting and hard. And then this might come in here, and the sort will rearrange the order of the sections to match the required order. And then we can use... Once it's sorted, we can use the image size, get the image size by just looking at the last section's virtual layout. That's kind of making an assumption that the last section actually gets mapped, which it isn't necessarily true. So we should probably put in a to-do here that's like more rigorous version. We probably want to scan backwards and find the first one that is mapped. We know that they're sorted, so it's still going to be the last one, but it's got to be the last one that's actually mapped. We might also want to think about how that affects this sort in the first place. Like, if something's not getting mapped, where does it belong in the sort order? You know, maybe the zeros are all bigger than everything else, so they go all on the end or something. I'm not sure. Then we want to set the file offsets. This is just another loop of layout, starting with the end of the headers and incrementing by file sizes and like the size of each data section as it exists in file, aligned by file alignment. And then we have a full layout. Cool. So what just happened is I took out the VOF here, which was what I was suggesting, right? So now, if we want to, we can come in here and say like, all right, this is done. We did it. Right? So VOF is out in this part, and it is added in this part, and all the rest of that is working. So we've done that. Now, this part is going to require understanding the constraints idea. So the reason this is working right now is just a sort of a fluke. I have intentionally laid out the data in text so that wherever data ended up, or so that if data ended up where I thought it would, right, that it would all work. But there's a coupling. The choice of these numbers here is coupled to the size of the text overall implicitly, right? If the text were to grow and grow and grow, we would have a bug. So 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and now we're getting garbage there. So to fix that, I would have to add in the one right here, because I've just bumped it up. I bumped the layout up implicitly, And there it's working again. So you see how that works? I am implicitly tying the size of the text section to this pointer here. So the constraints approach is to say, hey, this is hard-coded. Encode in here the knowledge of that constraint. When you go to give us a layout, we'll look at your constraints, and if we can, we follow them. But if we can't, we give you an error. And then the question is, can I think of how to implement it? So the exact part that is the layout part is, given these constraints, what would a constraint look like? I think we wrote down that a constraint is a pair of sections and a distance between them. So we would have to gather up any sections that are connected by a certain distance constraint. We could do it like an allocator, right? You'd have a space to fill, and then you'd say, okay, I have a section, where do I put it? And you'd grab a space for it. And then what you would do is you'd say, scan all the constraints. If any constraint tells us where to place a section relative to this one, then specifically go to that part in the space and allocate that part and put those sections there. If ever you're trying to meet a constraint and the space you need is already filled, then you have an error. If you never find an error, then you're good. If you get to the point where you've matched all the constraints for a particular section and you still have sections that aren't allocated, you just grab another one and you go again. Now, the only thing that could go wrong is if you say, go get me another spot in the space, you might pick a spot that can fit that section, but then that section has another constraint tying it to another section, and so you run into an error, but you made a decision that was arbitrary, and if you made a different arbitrary decision, you could have avoided it. We could say whenever there's a constraint putting two sections together, all the space between those sections is considered blotted out and not available for allocation unless it is forced there by another constraint, right? So like we start going and we find all the constraints that match a particular section, find all the constraints that match those sections, and we fill out the whole island, and then we mark the whole range from min to max. That's one island. We're done, right? And so then if there's any unallocated sections, they're not allowed to go inside that island. They create their own island, and once we're done, we have a bunch of these islands that we can then tie together in a final layout. That would guarantee that they fit. And I don't think it would ever be, I'm not expecting use cases of this where I have 4 sections and 2 constraints that cause them to interleave. That's like theoretically possible given what I wrote here, right? That is theoretically possible, but I don't think that's a real use case that I'm worried about. And so an algorithm that would do fine with, so an algorithm that assumes that's not happening, I think, and as a heuristic, would be fine in this case. Does that make sense? I don't know. I'm feeling a little low on steam. Like, we've done some good work. We did a lot of planning. Actually implementing constraints right now feels a little daunting. I could talk about relocations instead. I think relocations will be a little easier, so let's do that. Let's try to knock out relocations and call it a day. So a gen relocation is going to be like this. So it's something like this, and they look like this together. Here's the section. So one problem is we don't have section points to section isn't really going to work because we don't have like an indexing for our sections established by the time we're doing this. So I could say give it a section name like this. So I tell you the name of the section you point to. Or I could say give me this. So you already have to have generated the section. So it could be a thing where you're saying, hey, I want to generate the section, or I want to generate this relocation, but the section it's pointing to is a data section that I haven't generated yet. And I want to generate it later, but I don't want to have to generate all my sections first and then go attach relocations. I want to be able to say, hey, I'm making this section and I'm attaching these relocations. And now I'm making this section, I'm attaching these relocations. It's a little hard to know. Maybe you just need to say like, okay, if they're tied together, then you generate them ahead of time and you're building them up together. So it makes sense to generate the set of things that are connected to each other across relocations, set those sections up ahead of time, and then tie them in. We also know that the order might change at layout time anyways. So order isn't, if you're trying to control the order, you would do that with constraints or something like that, right? Not with the order in which you actually chose to generate things. So you might be able to get away with saying like, just generate them ahead of time. Don't worry, we're going to apply constraints if we ever want to control the order of the sections. This is just information for doing the relocation after the fact. Yeah, but it's still, it's tough. It's tough. I think this is a good way to do it, but I think this might be an intermediate solution. There might need to be more sophisticated stuff coming down the pipeline that I am seeing here. But let's start by building it this way, because that'll let us fill out like the bulk of what we do with this structure will still be correct. Gen relock. All right. Okay. And then what would happen is we would look at something like gen section. We would look at something like this, and we would go, okay, these need to get generated together. And then you can see I already have to specify so much. So it's not just the name of the section and the flags, but I also need to know the sizes on the data up front in order to first generate the sections, and then I can tie them together with relocations. And that's the problem. I'm like, this is going to have to get way more sophisticated. We're going to have to create sections before we have data for them, allow for the possibility of building data into them in pieces and attaching relocations in pieces. We're going to build them up loosely, much more loosely than I am. And so we got a ways to go to get to that level. But let's see. The relocation that we want for now is going to be like, here's the arena, here's the section for text that we are putting it onto. This points at the section for data. It points at point 0 there. Right? Points right there. And the location of this is 2, the size of it is 4. Now the only problem is this in concept makes perfect sense. It's cool. How do I actually apply it? Because this wasn't just it's not just a matter of saying take the final virtual address of this point after it's been located. This is actually a pointer of a specific kind. It is a pointer that is relative to this spot right here, right? In particular, what we want to say is, in order to point at this spot, the section data section offset 0, we're doing it relative from here. How is it supposed to know that? Sampy, I have a general arena implementation that I reuse at this point. I use a single code base for all of my projects. So I don't rebuild my arenas per project, but I also don't copy paste my arenas. I just use a single code base and run multiple projects from there. So it's a little bit, it's definitely in the reuse category rather than in the rebuild category, but it's a slightly different approach to reuse than you might be thinking. So I have it set up so that other people should still build their own arenas per their code base, because mine's not entirely ready to extract. I'm actually, one of my big projects is to take Mr. Fourth Base H and share it. So like here, once it's ready, arena along with everything else in my base layer will be a library at some point soon that you can just copy paste reuse. I haven't finished getting it that way yet. For the longest time, I was just doing it in the code base structure where I have a single code base and multiple projects that run from that code base. And so I didn't have reusable arenas in the copy paste sense. So there's a couple ways we can do this. We could encode something in here and then modify it, right? We could say this includes everything about the relative offset between these two things, except it assumes that they're both at the same VOF or something, right? It says, so once we know the actual VOF distance, then we have to add that in. there's some things about this that I don't actually know how I would specify. Like, what if it needed to address backwards? Can I subtract here? How would that work? Is it that this just looks like a 4-byte integer? Is it signed? Why would it be signed? Because rip is a 8-byte integer. So in all likelihood, this is just a positive 32-bit integer being added, which means the data would have to still be in front of text. And I would need a kind of constraint that is an ordering constraint, but not a fixed offset constraint, as well as the relocation. But the other problem is I kind of want to encode that this is -6 right now, right? Because we're saying in order to get from this is the offset. The rip value is right here. We want to go -6 back to get to 0, which is the offset we want, and then add in the v off, right? So this is the way I would encode this relocation, really, if I was going to just add something in once I knew the v offs, is that I would want this to be a -6, and I would add something. But that negative, again, it's not signed, so that's a little confusing. It's very easy to just say I want this to be a pointer to this offset, and I want the pointer to live right here. But the problem I'm having is that's not quite enough information. It at least needs to know that there's a bias of 6, right? It needs to know that the thing it writes here, yeah. Okay. I'm not going to think of them as relocations. I'm going to think of them as pointers. And the pointers are they all going to be relative? I don't know. I think a part of the problem here might be I need to go and learn more about different ways that I'm going to tie these together. Sometimes one of these things will point into another relative to each other, but sometimes one of these might point into another with a hard-coded offset. Well, I don't know about that. If that happened, then you wouldn't... The executable... I mean, it could work. It just would mean that the executable wouldn't be relocatable unless the executable itself had relocations built in too, you know? Let's just say for now this needs a bias. That might look like this. This will have a bias of -6. Yeah, this doesn't seem great. I don't know. I think... Well, it's a fine starting point. I think I know what I need to research next time to get better at this. Okay, so that's how we generate them. And then later we're going to do with that we need the layout. Because with the layout we can scan all these sections. That gives us a layout section. Gives us a gen section, and now we're going to scan all of the gen pointers. And then what has to happen is, based on however many bytes, we'll do one of these things. And we'll support 1, 2, 4, and 8 for now. We're going to reach into let's start with case 4. We're gonna reach into gensec data.string. We're gonna add in genputter relock off. Now here's a problem. I need to find the layout section for the pointer. So points to layout section equals 0. I'm going to scan the layout section count again. So we have a little bit of a nasty thing here. We got a doubly nested loop. Probably there's a way that this could be set up so that I don't have to do this, but since I keyed my sections as these pointers, but I actually can't iterate them that way, I have to iterate them this way, because I don't have VOFs in the gen sections, right? Just because I have a gen section doesn't mean I have the VOF. I have to map the gen section into the layout for that gen section. So there's a problem with the way I chose to key things. Got to think that through at some point. Okay. So when we find a match, when we find a layout section whose gen section matches the key on the gen pointer, then we've got the layout section that we need. And so now we've got the VOF of the destination plus the VOF of the starting location, and we can calculate how much to add. So so this is going to be the points to laysec VOF minus the laysec VOF, so the distance between the VOFs, plus relock off the points to off minus the relock off plus the bias. That should be the gen putter. Okay. All right, lots of issues with this version, but there's a day one sketch. So now, if I go into my text section and I just go, this is all zeros, and then I run the generator, that didn't work. Oh, hold on. Layout. Adjust pointers. Segfault, okay. We can deal with that. What's the matter here? Points to lay sec is null. Okay, so gen putter points to that section. Let's just take a look from here. What happened? I'm using I instead of J. There's the problem. 694 J F2 F3, so it's off. Boom. We find the section, points to lay section. Val we get is 1FF8. Okay, let's think this through. I think that bias of 6 was wrong, because I've already got 2 in there, right? So if it had been 0 right here, bias of 6 would be right. But since I put 2 here, I got to take 2 out here. There we go. Okay, so this is definitely not good. I don't know if it's obvious that this is not good from the outside, but this isn't quite what I want. For one thing, this and this are redundant to each other. This is the offset that we're trying to point to. This is the extra bias that we need to adjust, but those could be baked together. This is the location we're trying to modify. That's fine, but there's just so much here that isn't quite gelling. So I think that in order to do a better job here, let me go take some notes about what we got to do. Loose section relocations. We need to study the various forms of relocations. Study the various forms of addressing I need to think this all through in order to do a better job of this. And then another thing we need is it looks like we're going to need build up sections more gradually. I currently have to almost create the entire section when I specify a loose section. I have to know the final version of the data, the final size of the data. I have to know its flags right away and all of that. And so I might want to be able to say, like, when you start a section, you don't need to know everything about it. You're going to grow its data over time, but you can create it and then refer to it. We also want to fix that keying problem, though. So think about that. Probably do an ID system so we can just have everything always consistently indexed across parallel arrays. Okay, all right. I think that's it. I'm not going to do any more today. This was a pretty good one. We made some progress. We're chipping away at it. We've got a long project ahead of us now with generating these in competent ways. Lots to learn along the way. So let's do that, right? So I will probably be back either tomorrow or later this week, something like that. We'll keep making progress, and I'll see y'all around the internet. Oh, before I sign off, do remember, if you like the kinds of stuff I'm working on, if you like the fact that I can stream several times a week to work on this, or you like the videos I'm producing, or you want to see this project succeed, I'm super duper counting on people who are watching this who can to consider going and supporting or becoming a member on MrForth.com. You get a bunch of cool perks, and I get to keep doing this for you. So if you appreciate what I'm doing and the perks don't do it for you, keep in mind it's also keeping me going here. I can't do this forever for free. So do think about that. And with that, I will see y'all around the internet. Thanks for coming and checking this out. Bye.